Well, good evening, everyone. Uh, Let me start off with a quote. Technology, opportunities, problems are all kind of interrelated if you think about it, right? So some of us see problems where there are technologies, some of us see problems where there are opportunities, but some of us see opportunities where there are problems, right? So with that quote in mind, let me introduce you to myself. I'm Sudi. I'm an engineering manager at a company called Mandyam. And hopefully by the end of the session, I will be able to convince you that you should be treating AI more as a rocket fuel to fuel your career rather than treating it as a replacement engine, which is kind of the mood that's unfortunately set in today's scenario. So let's take a look at where the perception of misreading the AI shift, as I call it, comes from, right? So you see statements from all of these influential leaders. And one thing stands out, and that is essentially calling out that coding as a profession is most likely dead, and AI is going to write most of the code. I would not completely agree with that statement, and I think it's only one side of the problem, one side of the statement. Let's put this analogy in your head where if you think AI is actually making the bricks, there has to be someone architecting and building something out of those bricks. It becomes extremely important to understand the journey of where we have come from. And in the last 5 years, you've seen rampant progress in how AI frameworks have actually moved on. So 2022 was actually the time when ChatGPT became a rage, and it was almost touted as a replacement to Google, and Google would go out of business, which we have not seen happen. But 2024 was the time when we had the boilerplate AI code being generated by tools like your GitHub Copilot, and ChatGPT was your go-to prompt engine where you could ask questions and get instant answers. This focused more on speed and efficiency. However, if you made a poor choice of models, you would also end up with LLM hallucinations. And if your prompts were not good enough to provide the right context, you'd have problems getting the most accurate responses from these models. 2025 progressed significantly in terms of bringing in agentic programming into the foray. And tools like Cursor, Windsurf, which I happen to use, provided the ability to provide a better context across, say, singular microservices and a singular class. And that reduced the amount of slop code that was being generated. But having said that, lots of companies also kind of adopted this practice, which meant that there were no appropriate guardrails and there were no security ops that was placed. And this essentially resulted in AI slops. And lots of other issues. You definitely would have seen that on the media. Again, the challenges here were the poor guardrails and lack of security considerations. But then going into present, which is agentic engineering era, it's almost like a new discipline on top of software engineering, if I may call it that. You have context-aware agents where you're able to orchestrate solutions to solve complex problems. Treating agents more like your colleague as opposed to a coding engine, you're able to solve problems by giving it a business context and a problem to solve. And you have seen frameworks that have made into the market now, like Crew AI, Google ADK. You have tons of frameworks. It's really hard to keep track of all of this, right? I mean, all of this is fine. I mean, as a newbie to AI myself, I kind of feel it's quite overwhelming for me to kind of take it in the direction where I can actually use it. But one problem has still prevailed, if you think about it, in that agentic tools are only as smart as the context you give them. So if you're giving garbage, it's going to give garbage out. I mean, we've seen this in different talks today, where the focus like garbage in is garbage out. So how can you solve this problem? And let's see how this problem actually originates. So take a look at this. This should look familiar to most of us here, right? So we start off a company as a startup, and we see that everyone has a unified vision, and we are able to communicate easier, fewer number of heads, easy to solve, communication problems, and all of the knowledge that you have in the organization is really well documented. You push out that MVP, and everything goes fine. But you can see how the knowledge that is actually cheaper, not in terms of quality, but in some terms of accessibility, it goes into becoming more expensive, right? So as you go into an enterprise zone, you see documents are scattered all over the place. You have Confluence, Slack, PRs, and whatnot, right? So, and imagine a scenario where your subject matter expert departs a company. All of the knowledge is gone with them. So how would you solve this problem? And why this becomes important? So let's take a look at this model, which is called LLM Wiki pattern. If anyone knows who's Andre Karpathy, I'm sure most of us would know here. This model is called LLM Wiki, and the idea here is that we are able to take information and curate it in a way that you're able to run it through something called an LLM library, and which is also called incremental wiki compiler, which is able to take in all the information, and it's able to put the information out in markdown format, which is easily consumable by your models. So they understand this without you having to reparse the data, like for instance, RAG rederives, but the wiki remembers. That's essentially what the philosophy is behind this idea. And you can almost call this like a second brain, where you have like a 24/7 SME in your organization, and you're not relying much on the human. Obviously, if you have conflicting information across your documentation, you might still have issues where you might have to involve a human, but at least to that extent, you have automated the idea of contextualizing the information that you can supply to your models. You may ask me, where can I use the second brain, right? So this is, again, a very similar scenario. You have incident management in every organization. It gets chaotic when you have incidents, particularly on the weekends, and engineers have to scramble and try to solve problems. So I'd like to introduce you to the intelligent triage mesh. The idea is to take the data metrics, the LLM wiki that we discussed in the previous slide, and the standard ops procedure, your runbook index. So for every incident, your log patterns can be observed, and the SR is maintained in the runbook. And you can also take into account the app performance metrics, where you're taking your OpenTelemetry traces, your Datadog, everything. So essentially, feed it into the triage mesh, and it is able to. We are able to build a multi-agent orchestration engine that will be making a decision on whether something should be auto triage by an auto remediation agent, or should it be going to a human in the loop. So you can see how we are using the confidence as a threshold metrics there to make the decision as to whether something has to be autonomously resolved, or a human in the loop could actually solve that for us. So I think we've seen enough slides now. I would like to take you to one particular demonstration that I built for the purposes of this presentation. So the use case is really simple. We're trying to make payments to, like whatever amount you're trying to make. And also in terms of the payment failures that we're simulating on the left-hand side is now autonomously decided by my orchestrator on the right-hand side. As you can see, what it's using is a LLM wiki brain. That's basically what we built. And it is making a decision as to whether something has to be auto-remediated or a human in the loop should be involved. If you actually scan that QR code, you will see that it is implemented in Go programming language, and we are using Google ADK for this. And we have 3 agents out there: the main orchestrator agent, which is my Gemini, and the auto remediator and human in the loop are local models. So you can have a look at the code base. And yeah, it'll be good to hear some feedback on that as well. So the global policy overrides are also something that you have incorporated. You may ask me, like, why can't you do this with a regular application, right? The point here is that the policy engine is a second brain. And if someone goes and updates the rule books, it is automatically updated, in the sense that your product manager or your SRE or anyone who does not have any knowledge of the application code can actually go make the changes. So that way we're able to control the behavior of triaging in this particular instance. To summarize what we've covered so far, we have changed our perception from using AI as a coding engine, a vibe coding engine, to shift our mindset to agentic engineering in 2026. And we also demonstrated how we could use a contextual gap that you want to fill in using LLM Wiki, the Karpathy's method of second brain, and how we fed that into intelligent triage mesh, where we could orchestrate the decision that it had to make with regards to managing incidents, and how this essentially could reduce the mean time to recover, your DORA metrics that you use for managing incidents, for instance, how we could slash incident resolution times from minutes to hours to minutes, for instance. Again, I just want to summarize that we always have problems, and where we have problems, we have opportunities. It's up to us for identifying those opportunities and taking them as learning goal and use AI for that, or essentially just sit in a corner and think, one day I'm going to be replaced by AI. Thank you.
Okay. Do we have a question for Sudi at all? Yeah?
You're saying about the wiki. Yeah, good presentation, by the way. How does it update with all the new information and stuff? Is it via the tool that you mentioned, or because obviously wiki documentation changes, it evolves. So how do you deal with that?
Thanks for the question. Yeah, so the idea is that you have a specific LLM. It's called the librarian LLM. It is a standard approach where you are trying to curate information from myriad different sources into markdown documents, because as you might be aware, markdown documents are consumed better in the format that they are. So you will have an LLM library that's parsing through all the information across whatever context you provide. It could be your architectural design documents or your Confluence pages or your code itself, which is a source of truth for your platform. So take in all of that, feed it into the LLM library, and that's going to be like an offline parsing engine that's going to translate that information into markdowns. Hope that answers your question. Yeah, thank you.
Cool. Okay, round of applause for Sudi, please. Thank you.